Now, first we discuss about vapor pressure. What is vapor pressure? Vapor pressure is pressure exerted by vapor molecules on the surface of its own liquid. Every liquid on its surface will have its own vapors. Every liquid on its surface will have vapors of same substance. For example, water if you take, this is liquid water. On the surface of it you will have water vapor. What you will have is the water vapor. Now, this vapor molecules on the surface will exert H2O vapor will exert certain pressure on the surface of the liquid. On the surface of the liquid. What is the reason? The reason is simple, that these vapor molecules will hit on the walls of the vessels or on the surface. As a result, it will exert certain pressure. Now, here, so this process of converting, first of all, what is the reason for vapor to exist on the surface? The reason for vapors to exist on the surface is the molecule on the surface will have high kinetic energy. Molecules on the surface will have high kinetic energy. Therefore, their escaping tendency will be very high. So, as their escaping tendency is very high, they will try to, therefore, evaporation takes place. That is the reason. But at the same time, what happens is, first before that, what is the reason that on the surface if you take a particular molecule, what is the reason for the molecule on the surface to have more kinetic energy? The reason is that this now if you consider a molecule on the surface and a molecule on the bulk, the molecule on the bulk will have intermolecular attractions by many other molecules surrounding it. But a molecule on the surface will have intermolecular attraction only by lesser number of molecules, because on the surface it will not have. Then on the surface other gas, other air or is present, that will pull up this towards them. So that its escape, because of the lesser intermolecular attraction experienced by molecule on the surface compared to molecule in the bulk, the escaping tendency of this molecule on the surface will be more. So, it will try to escape out. That ability, due to that ability of a higher escaping tendency of the molecule on the surface, a vapor will be, this is escaping. So, vapor will be formed over here, right. Now, those vapors due to collisions, now when the vapor is formed, then the molecules in that vapor undergo intermolecular collisions. Due to that collisions, there is a possibility that kinetic energy of the molecule again decreases and it may come down. This is evaporation and this is condensation. So, here what happens is we reach a stage where evaporation and condensation will be at equilibrium. So, here what happens that due to high kinetic energy on the molecule on the surface, the escaping tendency more and evaporation takes place. Once the vapor is formed due to intermolecular collisions, for some of them there is a possibility that kinetic energy decreases. Again, the molecule with the decreased kinetic energy will be pulled back by the surface molecules into the bulk. So, the vapor molecule will convert back into liquid. This liquid molecule will be keep converting into these liquid molecules on the surface will be keep converting into vapor. So, as a result, finally what happens is a process of evaporation, process of condensation, both process of evaporation, process of condensation, both will be keep taking place simultaneously. As a result, we reach a stage where the rate of evaporation and rate of condensation becomes equal. That is what we call equilibrium state. Liquid and gas are in equilibrium. Now, pressure exerted by the molecules of the vapor on the surface of the liquid at that equilibrium stage is what is called vapor pressure, because if the system does not reach to the equilibrium, if the equilibrium is say towards evaporation, that means still more and more vapor is going to be formed. With increase in vapor content, pressure also increases, it will not remain constant. So, if once the equilibrium stage is reached and then if we measure the pressure, that pressure is what we call vapor pressure. So, in brief, vapor pressure is nothing but pressure exerted by vapor molecules on the surface of its own liquid at equilibrium is what is called vapor pressure, right. What is the significance of this vapor pressure, and what factors that vapor pressure is influenced by is dependent on, that if we look at it, the vapor pressure is of course dependent on the nature of the liquid. Obviously, it depends on the nature of the liquid. What nature? Whether the liquid is more volatile or less volatile. What do you mean by volatile? Volatility is nothing but ability to evaporate, right. Every liquid will have its own vapor pressure, and in fact, that is the reason this evaporation is something a continuous process. For a liquid to evaporate, no need of increasing any temperature. Normally, what we expect is a liquid to convert into a vapor. What always we think is that liquid is necessary to be heated. Liquid is not necessary to be heated. At any temperature, liquid molecules will be keep evaporating, because at any temperature liquid will have its own surface. On the surface, the molecules will have higher kinetic energy compared to that in the bulk. So, escaping tendency is always at any temperature, escaping tendency of molecules on the surface will be more than escaping tendency of molecules in the bulk. So, the molecules will be evaporating. That is the reason we will have water vapor forming from the lakes, rivers and all. If we keep a bucket full of water and if we keep it aside for quite a long time, after a long time if you look at it, there will be a decrease in the water level in the bucket. It does not mean that we have heated that water or anything, but water level slightly decreases. What is the reason? Because some water is evaporated. Why it is evaporated without changing the temperature? The reason is simple, as we discussed now. The molecule on the surface will have higher kinetic energy, so it will be keep escaping. If it is an open vessel, the evaporation is a continuous process. But if it is a closed vessel, then for equilibrium to achieve, this should be a closed vessel. Then the condensation also takes place. But if it is an open vessel, it is always only the escaping tendency, that is, liquid converts into a vapor, but vapor will not convert into a liquid at the given condition. That is in fact is the reason that in summer, where relatively the temperature is relatively more, at that higher temperature, more and more water will be keep evaporating, but condensation will not take place, as that being the open vessel. So, in summer, the water level in lakes, rivers and all will be decreasing, and even in some cases, in some areas, even they will be completely dried up. The reason is all the water is evaporated. When all the water is evaporated, does it mean that the water is heated to boiling point? No, absolutely no. It is not boiling point. It is the normal temperature that in summer, whatever the normal temperature, either 38 degrees Celsius or 40 degrees Celsius or whatever it is, that temperature, at that temperature itself, that whole evaporation is taking place. Because at elevated temperatures, the rate of evaporation is more, so more and more liquid is getting evaporated, but it does not mean that water is getting boiled over there, right. So, basically the point is that this evaporation is a continuous process. If it is a closed vessel, evaporation is followed by condensation also. If it is an open vessel, it is only evaporation, no condensation. This is what is the difference, right. So, in a closed vessel, evaporation and condensation will be at equilibrium, and that pressure exerted by the vapor at that equilibrium state is what is called vapor pressure. Now, if the tendency of the liquid molecules to escape out is more in one liquid compared to another liquid, for example, ethyl alcohol and water if you take. In the case of ethyl alcohol, the molecules of ethyl alcohol will evaporate more, or rather the escaping tendency will be more compared to the water molecules and the liquid water. What is the reason? In liquid water, there is a strong hydrogen bond. So, the molecules are tightly held up by hydrogen bonds. So, the escaping tendency is less. That is the reason we say the boiling point of water is more, that is 100 degrees Celsius. But whereas for ethyl alcohol, if you take, there also exists hydrogen bond, but a hydrogen bond is weak between two ethyl alcohol molecules. So, the escaping tendency is relatively more. That escaping tendency where it is more, where the liquid evaporates fast, that is what we call volatile liquid. Organic liquids like ethers, acetone, alcohols, these are more volatile liquids than water, right. So, this is what is volatility. So, now this nature of the solvent, effect of pressure, effect of temperature on the vapor pressure is what we are going to discuss now. Now, the factors affecting vapor pressure. One is nature of liquid. Liquids with high intermolecular attractions or strong intermolecular attractions, will have less vapor pressure than the one with weak intermolecular attraction. For example, ethyl alcohol, water, as just we discussed, this is P1, P2, boiling points T1, T2 if you take, vapor pressure, boiling point, P1 is greater than P2, T1 is less than T2, because in water strong hydrogen bond increases boiling point. Therefore, vapor pressure is less. Then what is the relation between boiling point and vapor pressure? Boiling point and vapor pressure are related as the temperature at which vapor pressure of liquid becomes equal to atmospheric pressure. That is called boiling point. Vapor pressure of liquid becomes equal to atmospheric pressure. The temperature at which vapor pressure of liquid becomes equal to atmospheric pressure is what we call boiling point. So, graphically we represent for pressure versus temperature graph. If you draw for different liquids, if you draw it like this, then this is liquid 1, liquid 2, liquid 3. The graphs, if you look at it, then this is atmospheric pressure, this is the vapor pressure temperature graphs, where the vapor pressure of liquid, now if you extrapolate this and the corresponding intercepts on the x axis, if you take T1, T2, T3 and the other side P1, P2, P3, if you look at it, then from the graph P1 is greater than P2 greater than P3, liquid 1, liquid 2, liquid 3, T1 less than T2 less than T3 is what you can observe. This is the boiling point. This is of course vapor pressure. At any given pressure for each liquid, what is the boiling point that you can measure. So, this is how it appears as. And the similar kind of graph also we can draw. Suppose if a non-volatile solute is added to a pure solvent, this is in liquid solutions actually we discuss. When a non-volatile solute is added to a pure solvent, then the vapor pressure of the solution will be less than the vapor pressure of the pure solvent. That is, even you can take pure solvent solution 1, solution 2, like if you take, then the boiling point of the this third one will be highest because the vapor pressure is decreased. That what is the reason for all that in the liquid solutions chapter is actually where we discuss that. So, this is the effect of nature of liquid on the vapor pressure of a nature of the liquid, effect of nature of liquid on the vapor pressure of the liquid. Next we see the effect of temperature and on effect of temperature on the vapor pressure, also the effect of pressure, what it happens. So, this all what we discuss. Now, the second thing is temperature. Vapor pressure of a liquid is given when a graph of pressure temperature is seen. Vapor pressure variation is like this for different liquids, as already we have discussed. So, this P is proportional to e power minus delta H by RT. This is the vapor pressure of a liquid is directly proportional to e power minus delta H by RT is the relation. So, basically from this what it is with increase in temperature, vapor pressure of liquid also increases. When the vapor pressure is increased, then obviously it becomes easy to reach the increased pressure. Now, this relation same thing. Now, if I write it at two different temperatures T1 and T2 Kelvin, P1 is proportional to e power minus delta H by RT1, P2 is proportional to e power minus delta H by RT2. So, from this log P1 by P2 is equal to delta H by 2.303 R 1 by T2 minus 1 by T1, where delta H is the enthalpy of vaporization. At T, first of all, vapor pressure is directly proportional to e power minus delta H by RT. This is from the graphs that is given. This graphs already that we have seen. Now, for this, if P1 is proportional at two different temperatures T1 and T2, vapor pressures are P1 and P2, then P1 is proportional to e power minus delta H by RT1, P2 is proportional to e power minus delta H by RT2. Therefore, log P1 by P2 is equal to delta H by 2.303 or 1 by T2 minus 1 by T1. So, where delta H is the enthalpy of vaporization. This is how with variation in temperature the vapor pressure varies. So, is the reason with increase in temperature, as already some vapor is going to be formed. So, as more vapor is formed, more force that it exerts on the surface and the walls. So, obviously, the vapor pressure increases, because increase in temperature increases kinetic energy. So, the kinetic energy of the molecule on the surface increases. So, escaping tendency increases. That is the reason vapor pressure increases. This is what the theoretical lineup. This is how that vapor pressure and temperature are related. This is so nature of solvent and effect of temperature. Then the third one is atmospheric pressure. The third is atmospheric pressure. The atmospheric pressure is another parameter that affects the vapor pressure, because if you take the example that water at mean sea level and water at a higher altitude, both if you compare, the pressure at higher altitude will be less and the density at mean sea level will be more. Density at mean sea level is more and compared to higher altitude, and pressure at higher altitude is less. Therefore, that is in fact the reason that water boils at very high temperature in the higher altitudes than at the in the mean sea level. So, the boiling point and vapor pressure are again in the inverse relation. So, to reach the atmospheric pressure, the temperature required will become more. So, that is the reason that the vapor pressure varies with the atmospheric pressure. Then besides this, the other factors that atmospheric pressure or the applied pressure, the other way also you can look at it as, if the applied pressure is more, then it favors the condensation, which increases the decreases the rate of evaporation. So, vapor pressure decreases. So, either way you external pressure or atmospheric pressure is another parameter. So, like this, the vapor pressure is measured for a liquid. It has a significance to understand its volatility and what are the factors. This also plays an important role. Vapor pressure of a liquid also plays a very significant role in determining the colligative properties, Raoult's law, where in the liquid solutions chapter we say that the relative lowering of vapor pressure of a liquid is equal to mole fraction of solute in the solution. So, that gives us about the colligative properties and many other applications also as well. Then next what we discuss is the other two properties, that is surface tension and viscosity.